Right. Hello, everyone. I have a very interesting guest for you today, someone who's been very influential to me, Professor Massimo Pigliucci. I hope I pronounced that right. Um, let me introduce Professor Pigliucci first. Professor Pigliucci is a philosopher of science and an evolutionary biologist. He happens to have a wide range of interests. He's written about the relationship between science and religion, philosophy of pseudoscience, the demarcation problem, and most recently on Stoicism. He has also debated, among other people, the intelligent design proponents, people like William Dembski and the insufferable Kent Hovind. So he also happens to have three PhDs in philosophy of science, genetics, and biology. So, well, I don't know where to start because your interest is so wide, but I want you to tell me a little bit about your background. How did you come about being interested in the things that you're interested in, and what made you take three PhDs? Uh, so please go ahead, Dr. Pigliochi.
Yes. Well, first of all, thanks for having me. It's a little bit of an unusual background, although it started out normally enough. I wanted to pursue an academic career in biology after my undergraduate degree. And so I went and did a doctorate in genetics at the University of Ferrara, which is in northern Italy. However, a few years later, I decided that it would be good for my career to just expand my horizons a little bit and go to the United States to get to work with some people that I was interested in at the University of Connecticut. The problem is that the person that I wanted to work with, Carl Schlichting, was very young at the time and did not have grants to pay for a postdoc, which is what I was looking for. And he proposed this strange deal where he says, well, you could come here and do a PhD. And I said, why would I want to do a PhD? I already have a doctoral degree. And he said, well, we can pay you a little bit more. You can teach a little less. You can do whatever research you want, and it'll be fun. And I said, sure, that sounds like fun. So that's how the second degree came about, as a way to get to the University of Connecticut and work with the person that I really wanted to work with. And it turned out to be a good investment in my career, because Carl and I worked very well. Since I already had a graduate degree, I had experience, I knew what I wanted to do, so it was a very good collaboration. And then I did resume my normal academic career. So I did get a postdoc at Brown University, and then finally a position as a faculty at the University of Tennessee, first an assistant professor, then I became an associate professor, then a full professor. But at that point, I got into my midlife crisis. Right, so I got into, it's like, okay, I've done this for a number of years now, and yes, it's been fun, but do I really want to do the same thing for another 2 or 3 decades? And when I was pondering this, the University of Tennessee had just hired a young philosopher of science, Jonathan Kaplan. And Jonathan had graduated with a thesis at from Stanford University on gene-environment interactions, on nature and nurture questions, which is what I was working on as a biologist. And Jonathan, in fact, knew my work as a biologist, had cited it in his thesis. And so he looked me up. He called me up when he came to campus, and he said, hey, I know your work. Why don't we have a cup of coffee and talk about it? One thing led to another. We hit it off very well. We collaborated on several papers, joint papers, in essentially philosophy of science. And philosophy had been an interest of mine in the background for a long time. And so then it struck me that, hey, this is one way to overcome my midlife crisis. I could change field. And so I decided to go back to school. I asked Jonathan if he could be my advisor, and he was very surprised when I asked him that, because I was a full professor. He was a young assistant professor before tenure, but things worked out. And then a few years later, I defended my thesis in philosophy of science, and a few more years passed before I was able to actually switch fields entirely. So I've been a full-time philosopher since 2009 at the City University of New York.
So I didn't know that. I had been aware of your work with Professor Kaplan because I read the book on evolution. That I think it was called "Making Sense of Evolution." It's a very
That's right.
interesting,
That's my thesis. That was my
somewhat
thesis.
technical.
Yeah.
Oh, that was your thesis.
Yes. Mm-hmm.
Ah, well, it's a very interesting book which I recommend
Thank you.
everyone to read, and it's very, despite being technical, it's very readable as well. So there's that. Uh, but I want you to talk about the most recent book of yours that I've read is The Nonsense on Stilts, which is
Right.
on philosophy of pseudoscience. And I want you to talk about the demarcation problem and why you felt the need to have such precise classifications, because it's not, because in most skepticism, books on skepticism, the classifications are, either it's science or it's pseudoscience, but you talk about quasi science, you talk about soft science, hard science, and pseudoscience, and why did you feel the need to make those kind of distinctions?
Well, so in general, philosophers like sharp distinctions, right? This is black and that's white and that's the end of the story, right? But the problem is that people have realized that decades ago that that's just not going to work for a lot of complex concepts such as science and pseudoscience. They're complicated. They have fuzzy boundaries. They are not black and white. There's all sorts of shades of gray. And actually, this is not a problem. It's an interesting feature of these concepts, right? Because if you actually really did have a very sharp separation between science and pseudoscience, then it would be actually more difficult to understand where pseudoscience comes from. Why do we have this thing in the first place? If you start thinking about the separation between science and pseudoscience, not as a sharp line, but as a kind of a continuum, as a landscape with intermediaries, then it actually makes more sense. It's like, oh, now I understand. There are at one extreme, there are things that are clearly science, let's say fundamental physics or evolutionary biology. At the opposite extreme, there are things that are clearly pseudoscience, such as creationism, astrology, and things like that. But then in the middle, we have all sorts of stuff that it may be, it may go one way or the other. It depends, and maybe hasn't gone one way or the other yet. So, for instance, parapsychology for most of the 20th century was on the borderline. It was like, most people would probably have considered a pseudoscience, but there were professional psychologists who were doing actual research in real university departments about things like telepathy and clairvoyance and telekinesis. It turns out that now we know enough about it that I think it's pretty firmly into the non-science category. But it took time. And there are some disciplines that are still at the borderline, like, for instance, evolutionary psychology, which is an attempt to apply evolutionary theory to the study of human behaviors. In other words, to explain human behavior mostly or exclusively on the basis of past evolution and genetic makeup of individuals, as opposed to culture, society, psychology, et cetera, et cetera. Now, the basic idea of evolutionary psychology is perfectly fine. Obviously, we are animals and we have behaviors, and our behaviors evolve. There's no question about it. But the devil is in the details. Once that evolutionary psychologists start making specific claims about modern behaviors, like, the reason men in their 50s buy sports cars is because, it has to do with their genetic makeup that goes back to the Pleistocene. Well, that becomes a little bit more complicated. It's difficult to test. It turns out, or sometimes, in fact, often impossible to test. And so these becomes kind of like stories that are plausible. It's certainly possible that is the case, but is it science? Does that make it science? If we don't have direct empirical evidence, if we can't do experiments on these kind of things, then I would say no. That doesn't necessarily make it a pseudoscience either, because they're not making claims that are entirely out of the realm of possibilities. So it's one of those fields that is in between. And so it becomes interesting to study what philosophers call the demarcation problem, the distinction between science and pseudoscience, because it turns out that there are a lot of fields and there are a lot of hypotheses and there are a lot of claims that have been made. They're kind of in between. We're not really positive that they fall necessarily one way or the other.
Well, is it the technique that differentiates them, or is it really the axioms that define the paradigm of the field? Because, for the longest time, the axiom in science, the accepted axiom was that of methodological supernaturalism. That is, there is a God. All of the scientists believed in the existence of God, Newton, and they thought that they were making, by studying science, they were studying the wonders of creation everywhere, which ID proponents like to tout a lot nowadays. So, given that, uh, do you think that if a theory, something like parapsychology, maybe, like, it might have crazy axioms, but does not mean that the techniques that they employ are necessarily, uh, you know, out of the realm of science? Animalistic psychology do just what parapsychologists do, minus the crazy axioms. So
Right.
is it the technique, or is it?
I think it varies. It depends on the field. So, for instance, astrologers clearly do not use any scientific methodology. They just don't seem to be interested in even testing whether their predictions are correct or not. And when scientists have tested them, not surprisingly, they found that astrology doesn't actually make reliable predictions. There was a famous article published in Nature magazine several years ago that actually did test directly the predictions of a number of top astrologists and found that their level of accuracy was exactly what you would expect by chance, right? If these people were just guessing instead of using whatever methods they claimed that they were using. So there are some pseudosciences that clearly the problem is methodological. They're not doing what science normally does. But then there are other cases where the methodology is correct. It's just the people insist in not accepting the results of that methodology. For instance, I mentioned a minute ago research on telepathy. Research on telepathy has actually been, and both telepathy and telekinesis has been done in a scientific, somewhat rigorous way by actual psychologists for many years. These people were in the lab and they were trying to replicate the results. They used the controls, etc. So they used essentially all the trappings of the scientific method, but they kept coming up empty-handed. The result was always, no, it doesn't work. And so what makes parapsychology, I think, a pseudoscience at this point is not that they're not using the right methods, is that they refuse to accept their own results. They insist in thinking that there is something there, when in fact it doesn't seem like there is anything to buy it into. So it depends. Sometimes it's a sociological phenomenon that makes something into a pseudoscience. Sometimes it is a methodological problem. It usually what pseudosciences have in common often is the refusal of the believers to accept the verdicts of inquiry, right? So ufologists, for instance, UFOs, the same idea. It's not like UFOs have not been investigated. They have been investigated for decades, right? But so far, at least, nobody has really come up with any kind of tangible, serious empirical evidence that there is such a thing as flying saucers visiting Earth. So at this point, it would be time for these people to say, okay, well, we were wrong. But they don't. And that's what makes it into a pseudoscience. It's not the claim necessarily, because it's perfectly possible that aliens are visiting Earth. It's hard to imagine because we know that there are, the laws of physics limit the speed of interstellar flight to the speed of light, which is pretty slow by considering the kind of distances that need to be covered. But it's not impossible. I mean, you could do it. So it's not that the claim itself is necessarily impossible. It's that once the claim is made, people start looking for evidence, and when the evidence is not there, then the rational thing to do would be to say, okay, that's the end of the game. But for these people, it is not. And that's what makes it into a pseudoscience, the insistence that there is something there, even though we have pretty damn good reasons to think that there is nothing.
Well, interesting that you mentioned that, because one of the things that fascinate me about these sort of quasi-scientific fields is that they're pretty mainstream, the search for the existence of extraterrestrial intelligence, which I did not think of as, quasi-scientific until I read your book and really thought about it, because, Carl Sagan has been, as he has been to most science enthusiast and inspiration. So to have that conceived of as, because it seems to me like mathematically it's highly likely that there are extraterrestrial existence, which does not mean that empirically that will turn out, as good. So why don't you go ahead and explain in simple words why you think SETI is a quasi-science? I think you're right that it comes dangerously close to pseudoscience, if I remember correctly.
Yeah, SETI is an interesting case because, so you mentioned Carl Sagan. Carl Sagan has always been one of my role models in science. And in fact, when I was younger, I was definitely interested in SETI. And I still am. I wish that tomorrow morning, the New York Times publishes a front page and says, "We found them. They're out there." Right? That would be great. That would be a lot of fun. So it's not like I have anything against that sort of research, but the reality is that SETI as a field of research, although it is done by legitimate scientists, it's done by astronomers, and it is done by using legitimate scientific equipment, radio telescopes, right? Even so, there is a sense, not only, of course, there's no results, right, so far. People have started doing SETI at least since the 50s. So not we're talking about 7 decades of more or less continuous research in SETI, and we got exactly 0 data points. We have absolutely nothing. Now, that's discouraging, obviously. It doesn't mean that it's a pseudoscience, but it certainly doesn't make me very confident about the possibility of discovering something. It's like, oh, come on, 70 years, we haven't looked all over the place, we haven't found anything. It's at least discouraging. So that's one point against it. That is a very unusual science in the sense that there literally is no data at all at the moment. The other thing that makes it problematic, makes SETI problematic, is that there is essentially no theory behind it. The only piece of theoretical work, substantive theoretical work that SETI has is the famous Drake equation. And the Drake equation is a simple equation of based on conditional probabilities that tries to estimate the number of intelligent and technologically capable civilizations in the galaxy. And that estimate depends on variables such as the number of stars that can host planetary systems, the number of planets that are situated in a zone that is favorable to life, and the number of times that life actually has originated, the number of times that life once originated has yielded intelligence, and then the number of times that intelligence has actually turned into a technological civilization, and then an estimate of the length of, the time span of these civilizations. How long does a technological civilization last? So there are 2 problems with Drake's equation. The first thing is, not only it's the only piece of theory basically underlying SETI, it's a very old one. It was published right at the beginning. Frank Drake published in the 1950s. That means that the entire field has not theoretically advanced for 7 decades. That's not good news, right? This is something very unusual in science. Usually scientific theories keep being churned out and updated all the time. SETI is definitely an exception. Again, does that mean that it's a pseudoscience? No, I don't think so. But it certainly is a bell that should, an alarm bell that should be going off and say, wait a minute, what's going on here? The other thing is, some of the variables that make up the Drake equation, we have pretty reasonable estimates for those numbers. Like, we know how many stars there are in the galaxy, give or take. And over the last decade or two, we've been discovering a good number of extra solar planets. So we start having some idea, although statistically only approximate, but still we have some idea of how likely it is that there are planets around certain stars. But that's it. Almost all of the other parameters either are unknown or are unknowable. Like, for instance, the typical length of existence of a technological civilization. We have no idea. There is no way to tell. We have no idea how to tell that, how long that would be, because we only know of one technological civilization, ours, and we've been a technological civilization, meaning capable of radio communication, for only a century or so, right, or a little bit more. And moreover, we don't know how long it will last. We don't, we could go extinct in the next 10 years or 100 years or 1,000 years, who knows? So that number is there's simply no way to put on that variable. There's simply no way to put a number around it. The chances that life originates in a planet that is in the right habitable zone, it's also entirely unknown, because we only know on one case in which that happened. That's planet Earth. So unless we start having, and it's very difficult to imagine how that would change in the near future. It's not likely that we're going to find life elsewhere in the solar system. We may or may not. We're not anywhere close to do it. So there is so much uncertainty, in other words, that it's kind of hard to imagine why these whole efforts should be taken seriously. There's an additional problem if you think about it. Basically, the whole SETI program is based on a fairly big assumption that the aliens that are out there have pretty much the same psychology as human beings, right? Because why would they bother communicating with other civilizations? I mean, that assumes that they are curious and that they want to make contact. In other words, it assumes that they have a psychology similar to humanity. But why? We have no reason to assume that other civilizations actually have anything near a human psychology. So the entire thing is very anthropocentric from that perspective, right? It's really looking at us and projecting things onto other civilizations. Now, one thing that it's interesting you said a minute ago is like, well, mathematically speaking, isn't it improbable that there are no other civilizations? Well, until some time ago, a few years ago, I would have agreed. I would have said, yeah, sure, it sounds like it. But in reality, the answer to that question is we don't know. We have no idea how probable it is. It's possible that the galaxy is teeming with civilizations. It's possible that there are, hundreds of thousands of them. It's also possible that we are alone, that we're just a fluke of nature, that we're just like, an anomaly. We literally have no idea. Why not? Because in order to estimate probabilities, you need multiple samples. That's what there are two ways of thinking of probability. Probability, classically speaking, is simply a frequency. It's a estimate of the frequency of a phenomenon. Okay. So if I say, for instance, that the probability, when I say that the probability of having a head instead of tail by flipping a coin is 50%, what I mean by that is that if I flip the coin 100 times, on average, I'll get 50 times head, right? So that's called the frequentist approach to or interpretation of probability. Well, we can't do that with SETI because we don't have a frequency to estimate, right? We only have one case, and one case doesn't make a frequency. We need a distribution of cases. We need a population of cases. We don't. So because we have no data other than our own, it literally is meaningless to talk about the probability of another civilization existing. The second meaning of probability is the Bayesian one, and specifically as a which is the other major theory in probability, the probability business. And in Bayesianism, a probability is really an estimate of the belief of the agent. So when I say I think it's probable then that it's going to rain tomorrow, what that means, if I say it, not a professional weather forecaster, it means that I believe that it will rain, right? Or if I say it's likely that there is a God out there, what that means is this is my belief. It's not an objective feature of the world. It's just an estimate of my own beliefs. But the problem with estimates of your own beliefs is that, of course, your beliefs estimate might be radically different from mine, and there's no way to adjudicate which one of us is actually right. So all of these are problems for SETI. Do they make SETI into a pseudoscience? No, I don't think so. We're not talking astrology. We're not talking parapsychology. But do they make it into a full-fledged science? I don't think so either. Now, of course, this could all change, as I said, tomorrow. If we actually do discover just one, reliable signal of another civilization, then the whole thing changes completely. Then that would be an actual thing out there that we need to deal with, and all of a sudden the field would certainly gain legitimacy. But until and if that happens, I think that SETI remains somewhere in limbo, somewhere in between the science and pseudoscience.
Do you think that it should do you think that it should be disbanded, or do you think it's meaningless to do that? We should find other avenues maybe of doing the same kind of search, or do you think that it's a valid search but it's not exactly science?
I think that it is a interesting search, and it might succeed. And therefore, if there are people who are willing to put the time and the money into it, they should do it. The question to me is, number one, have people perhaps not paid enough attention to to other ways of doing this, right? Perhaps there are other approaches instead of just scanning the sky with radio telescopes that we might use, although I'm not sure what that might be. But there are lots of clever people out there, and perhaps somebody might figure out a better way to do this. The other, I think, more pertinent question is, well, do we want to spend that much money? Because it's not cheap, right? It's not very expensive, but it's not cheap. We're talking millions of dollars every year. And is it a good investment of our money and time for our radio telescopes and for our scientists to do that sort of thing? Or maybe we should be doing something else. Now, this is a serious question, which is often raised. In fact, it's regularly raised in science. I've been throughout my career as a scientist, I've been on several panels of funding agencies where I had to help make a decision whether to fund this research or that research. And there's always, my experience is, there's always many, many more possible research projects that are proposed and they're interesting than there is money to actually fund them, right? When I was working, for instance, on grant proposals for the National Science Foundation, I realized that only 2 to 3% of the proposals that are submitted every year actually get funded. That means 97% of research that scientists propose, there is not enough money to do it. So that means that it makes sense to ask yourself, well, given that, should we not give that kind of money to something else other than the SETI project? And that, I think, is a reasonable question to at least raise and at least talk about it, rather than just take for granted that, of course, that's a good idea. There's no of course in science. You have to argue, why is this a good idea? And in fact, why is it a better idea than others that are being considered at the moment?
Yeah, well, I think it's a completely valid question, because there might be many research proposals that will have certainly more promising outputs, and within more limited time, with a
Right.
short, shorter time limit, that uh, could benefit from the research program, from the research funds that we give to programs like SETI. It's been, I think, 20 years and no results. So certainly at least some of that money could go to other research funds. Um, but one of the things that you also talk about in your book is physics, and uh, you know ask whether physics is turning into, or at least parts of physics are turning into some sort of philosophy because of
Right.
the idea of parallel walls and quantum interpretations and things like that. So, and since your book, there's been a lot of other books that have come about arguing essentially the same thing. The most popular one being Hossenfelder's Lost in Math,
Yes.
essentially making the same point that physics is becoming lost in its search for beauty instead of more empirical research. So what do you make of it?
Yeah, those are all very good examples in fundamental physics. There are three examples that we're talking about here. There's string theory, there is the notion of parallel universes, and then there are different interpretations of quantum mechanics. All of those, all three of those are good examples of what we were talking about at the beginning of this conversation. That is, of the notion that the difference between science and pseudoscience is not a sharp distinction, but a continuum landscape. None of these three ideas, different interpretations of quantum mechanics, string theory, and parallel universes, are anywhere near pseudoscience. They're nothing like astrology or creationism or anything like that. But are they actually science? And I raised initially, I was one of the first ones, I guess, years ago to say maybe not. And now there are several people like Sabine Hossenfelder, Jim Baggott is another author that has published books in the same general vein. They say, look, hold on a second here. Here we have scientists, physicists like Sean Carroll or like Brian Greene, very fairly famous physicists that actually have written a lot also for the general public, that make claims on behalf of physics, such as there are parallel universes, or the multiple worlds interpretation of quantum mechanics is the correct one, or string theory is the best theory about the fundamental nature of reality. They're making these claims without empirical evidence. There is no empirical evidence that favors any of these things. We have no evidence of parallel universes. In fact, it has been argued, from my understanding, when I talk to some of my colleagues in physics, my understanding is that it is in fact impossible to get empirical evidence of parallel universes, even if they existed, because there is no communication between those universes, even in theory. It is possible in theory, but definitely not in practice, to get empirical evidence in favor of string theory, because the energy that the levels of energy that would be needed in a particle accelerator to actually produce some of the effects that are predicted by string theory are orders of magnitudes higher than the ones that are capable of being produced in current generation particle accelerators. So it may be possible in the really, really distant future, but definitely not anytime soon. And there is no empirical evidence that discriminates between different interpretations of quantum mechanics. Well, now, if there is no empirical evidence, if these theories don't, as philosophers of science put it, if they don't make contact with the empirical, then what are we talking about? Why are we talking about it in the first place? They're just speculation. So Sabine, as you mentioned, refers to those as being lost in numbers. In other words, being lost in mathematics. I think of them as speculative metaphysics, which is ironic because a lot of the people that are pushing these notions are actually very dismissive of metaphysics. They, which is a branch of philosophy, of course, because they think that metaphysics is a waste of time. And it's kind of ironic that somebody who thinks that metaphysics is a waste of time then spends a lot of time writing books and producing YouTube videos on essentially a metaphysical speculation. So again, now, does that any of this amount to pseudoscience? No, these are definitely not pseudoscientific notions. String theory is based on quantum mechanics and it's an extension of quantum mechanics, general relativity, and the standard model in physics. So this is, and those are all three very seriously empirically established. It's not like we're talking, nonsense here. The notion of parallel universes does come out of certain theoretical models in physics, the basis of which is itself based on grounded on notions that are empirically confirmed. And of course, quantum mechanics, no matter how you interpret it, it's real. It's not like it's in fact arguably the best established scientific theory of all times. So while there is a problem to interpret quantum mechanics, meaning to give some kind of understanding, human understanding to what exactly it is that we're observing, the observations and the theory itself are beyond question. So we're not talking about pseudoscience for sure, but we're also not talking about science. And one of the things that worries me is that there are some colleagues, both some philosophers and some theoretical physicists, who over the last few years have started talking about post-empirical science. That is, they're starting suggesting that perhaps some of these theories should be tested not empirically, but they should be evaluated on the basis of things like beauty and coherence and mathematical properties and things like that. And that's where Sabine really gets upset and says, no, wait a minute. And I agree with Sabine. As soon as you lose contact with the empirical, you are not doing science anymore. You may be doing something interesting. I don't know. I mean, speculative metaphysics might be interesting, but it's certainly not science. And so it should not be sold to the public as science, which it is at the moment. It should not be funded as science by funding agencies. Again, a lot of theoretical physicists have been complaining, for instance, over the last decade or two, that they can't get funding to pursue alternative theories to string theory because all of the money goes to string theory. Okay, and so it's ironic that one of the arguments that string theorists put forth is like, well, it's the only game in town. We don't have alternatives. And the rest of the community says, well, of course we don't have alternative. You guys keep gobbling all the money. All the postdocs, all the graduate students, all the faculty position go to string theory, or have gone to string theory for the last 2 or 3 decades. So no wonder we don't have any alternative. There's no incentive to have any alternative. But that doesn't mean that alternatives are not possible. It's just that we need to slow down and give them time and money and effort in order to be developed.
Do you think these theories perhaps fit better into the model of maths, which is, math is in science, it's not empirical, but it has, precise models and things like that. So perhaps these ideas should be treated more as an extension of that, perhaps models, maths, rather than physics, which is considered to be an empirical hard science.
Yeah, no, I agree. I think we should think of string theory as a branch of mathematics, not of physics. Now, and you're right, although that's not a popular opinion even among physicists, but you're right when you say that math is not a science. And that's because math it has no need for empirical confirmation. You don't do experiments in order to confirm mathematical theorems. It is certainly the case that math is occasionally very useful to science. There's no question. It's obviously a very, very good tool for science because it helps us making sense of empirical findings. It helps us analyzing empirical findings, et cetera, et cetera. But the majority of what mathematicians do has nothing to do with the empirical world. It's about possible worlds. It's about logical possibilities, not about the reality that we call the universe. And that to me is the distinction between mathematics and science. That mathematics deals with possible universes with essentially an infinity of possibilities, theoretical possibilities. Science deals with one only of those possibilities, the one that actually is instantiated in the universe as we understand it. So if you are talking about mathematical constructs where there is no need for empirical confirmation, then I'm fine. Then sure, yeah, then you can say, look, we're talking about parallel universes or string theory, but we don't really think of those as physical things. We just think of them, want to explore them as interesting mathematical objects. Then nobody would have a problem with that. The problem is when you try to sneak in and what is essentially mathematics or metaphysics for science. That's where it becomes problematic.
I think Nick Bostrom does that because he makes a mathematical argument and he's very clear about the fact that because he is a philosopher and he's very clear that
Right.
he's making a philosophical and mathematical argument. But the same simulation hypothesis, when it comes to physicists releasing it, they, on the other hand, seem to be making a more robust empirical argument, and I think that distinction isn't clearly made, largely because I think that there is a disconnect between the philosophers and the physicists, which was very clear in your conversation with Lawrence Cross,
Yes.
even that conversation that you, you and Professor Dennett had with Lawrence Cross. So that disconnect needs to be bridged somehow.
Yeah, I agree. And it's true that there is a disconnect between physics or science in general and philosophy. And that actually doesn't necessarily bother me because those are different disciplines. Philosophers are interested in different things from scientists. They go about it in a different way. So fine, there's also a disconnect between philosophy and literature, but that doesn't bother me either because they're different fields. What bothers me is that some scientists seem to have a dismissive attitude toward philosophy. They think, Lawrence Krauss being the obvious example, they think that philosophy, although there are others, Neil deGrasse Tyson is another one, and they think that philosophy is a waste of time, and that judgment is unwarranted for a number of reasons. The main one of which is that these people know nothing about philosophy. And I know this for a fact. I'm not just making up. I once asked, I had an interesting conversation with Neil, and at some point, he was making all these statements about, oh, philosophy is useless here, is philosophy useless there. And I said, Neil, just as a curiosity, how many papers or books in philosophy have you actually read? And he looked at me and he said, none. And I said, so what are you talking about? Well, imagine if I went on and on and on, telling you that cosmology is a waste of time, that quantum mechanics is a waste of time. And then at some point you stop me and you say, wait a minute, but how many books have you read in cosmology? And I'd say nothing. Wouldn't that be bizarre? Wouldn't that be a little strange? I mean, you're literally talking about something that by your own admission, you know nothing about. So shouldn't you shut up? Wouldn't that be intellectually more honest? And also, there are some areas of philosophy that do overlap with science. I mean, I'm a philosopher of science, and of course, as we talked about earlier, originally a scientist. So there are some areas of overlap. There are some areas where it is actually interesting to look at the same problem from both the philosophical and the scientific perspective. For instance, in biology, one of the things that biologists have been debating for decades without getting anywhere is the species concept. What is a species? How do we tell a species from a non-species? What makes it so? And species are a fundamental category in biology. So you would think that biologists would know what a species is, but they don't. And they've been talking about it for decades without ever arriving at a conclusion. That tells you that the problem is, to some extent, not empirical, but conceptual. In other words, it's a philosophical problem. And sure enough, in that area, there's a lot of papers that are written by philosophers or biologists where they talk to each other. a lot of biologists that are interested in species concepts to read the philosophical literature, and vice versa. The philosophers read the scientific literature. So there are areas of overlap. There are areas where philosophers and scientists can meaningfully and productively talk about the same kind of stuff. But broadly speaking, philosophers are on one side of campus and they do their thing, and scientists are on the other side of campus and they do their thing. And it is really strange to me when one of the two sort of crosses campus and says, "Oh, what you're doing is useless. It's irrelevant." It's like, irrelevant to whom? It's let's see. The late Stephen
Also,
Hawking
that
was
is,
another one. Sorry.
yeah, that the argument that philosophy is useless is actually a philosophical argument, not a scientific one.
It is, exactly. It is. And that argument was made by Stephen Hawking, for instance, the cosmologist. And he wrote a book on which is actually a book that I would look at as a book on the philosophy of cosmology. But ironically, he starts that book by declaring that philosophy is dead. And how does he reach that conclusion? Well, because philosophers have not solved any scientific problem for the last century or so. And it's like, that is very strange. That would be like saying that science is dead because it hasn't solved any philosophical problems for the last 100 years. That's just a very strange way of putting things. Philosophy is simply not in the business of solving scientific problems. We got science for that, right? It's its own discipline. So why would you expect? I mean, would you say that literary criticism is a waste of time because literary critics have not solved any problem in physics? Like that would strike people as bizarre. It's like, why are you even making that comparison in the first place? And yet, some physicists, fortunately not all, there are some modern physicists who actually are far more sympathetic to philosophy, Sean Carroll being one of them, for instance. But in some cases, it's like you have to scratch your head and say, what are these people thinking? These are smart people. I mean, deGrasse Tyson, Krauss, Hawkins, these are really smart people. So it's like, why are they actually saying what they're saying? And my answer is, from having met many of these and have talked to them, my answer is a combination of ignorance and hubris. They think that they know better precisely because they're smart, and precisely because they work in physics, which is the self-professed queen of the sciences. So of course it's very self-important. These are people who think that they can talk about things about which they don't know anything. And if philosophers have done anything since Socrates, is precisely to try to remind people that most of us don't know as much as we think we know, and then therefore we should slow down and be a little bit more cautious when we make pronouncements.
Well, this idea of scientism, I think, is increasingly became popular with the sort of new atheist movement and things like that,
right,
which you've been a critic of. So, what strikes me particularly weird is the fact that despite claiming that philosophy is useless, most of these scientists, when they make these they write these extended books and give lectures on philosophy being useless, and they're not making a scientific argument there. They're making a philosophical argument, but they're not accepting that. Sam Harris does this when he talks about the facts and values distinction, or Lawrence Krauss does this with his book A Universe from Nothing, where he argues
right,
against the existence of God. So he's making a philosophical argument, but he's not admitting to it, in the same sense that intelligent design proponents are making a philosophical argument but claiming that it's science.
That's right. Exactly. And that is so obvious if you look at it from the outside, that then you have a hard time understanding why these people don't realize that that's what they're doing. But you're absolutely right. Krauss in that book makes philosophical arguments, bad philosophical arguments, because he's not a philosopher, right? Richard Dawkins in The God Delusion uses philosophical arguments, not science. to arrive at his point, and they're bad philosophical arguments because, again, he's not a philosopher, so he doesn't know what he's talking about. The philosopher could write a much better book on why there is a God or there isn't a God than Richard Dawkins or Lawrence Krauss. But even that would be, wouldn't bother me to see scientists who are doing bad philosophy, is if at least they would admit that that's what they're doing. It's like, hey, I'm trying my hand here at philosophy. I may not be as good as the professionals, maybe I should get some help here, but here's my best understanding of something. I mean, you can make, the kind of arguments, for instance, that Dawkins makes in the God Delusion are the kind of arguments that, my undergraduate students would make. And they're okay. They're not particularly sophisticated. They don't stand up to the most sophisticated scrutiny, but they're pretty reasonable. And if he were actually to admit that, it's like, look, this is outside of my sphere of competence. I'm a biologist. This is, however, not what I do normally. But I wanted to write a book that put out my opinions about these things. That would be perfectly fine. Anybody can write books about all sorts of things, and nobody should, try to suppress them or anything like that. But when you write a book and with a big fanfare, and you make a big deal out of the fact that somehow you have come up with really good reasons not to believe in God, and then it turns out that those reasons have been debated for 2,000 years, and you didn't know it because you didn't do your research, then you look like a fool.
Well, weirdly enough, I recently read Stephen Mayer's book, The Return of the God Hypothesis, the Intelligent Design Proponent. And I found his work to be, he may not be scientifically as rigorous, but he is philosophically more rigorous than, say, someone like Richard Dawkins.
Right. Yes.
So
Unfortunately, that's true.
So you talked about literary criticism, and I wanted to talk to you about evolutionary psychology, and that reminded me that Gard Sud, who's an evolutionary psychologist, uh, he in one of his podcasts or interviews, he said that literary criticism is essentially useless because it doesn't deal with facts and things like that, and literature should be studied from a Darwinian perspective. So
Yeah.
what I find in a lot of these evolutionary psychologists is is on one hand they emphasize on interdisciplinarity, right?
Yeah.
So they claim that they're taking insights from anthropology, philosophy, psychology, biology, and all of these fields, but at the same time they refuse to learn the basics of that particular discipline.
Yeah.
They
Yeah, you're right. You're absolutely right. I mean, it's really strange. So I was once at a conference where I was invited as kind of the token skeptic, evolutionary psychology conference, and I was the only dissenting voice basically there. And this conference was about applying evolutionary psychology insights into literary criticism, so to the study of literature. And I still remember one of the major talks was about what evolutionary psychology can teach us about Jane Austen's novels. Okay. And you'd be surprised to discover this, but apparently Jane Austen's novels are about marriage, money, and making babies. Does that surprise you? It's like anybody who has not even read the novels, but just look at the Wikipedia summary of Jane Austen's novels will be able to tell you the same thing. Yeah, no kidding, they are about those things. So what's the big insight there? You're missing a lot of what's going on in Jane Austen if you just reduce it to those three things. I mean, you can make the argument that most of human literature is about struggle for power and sex and fame and glory. Those are the three major motivators of human behavior. So what? What have you told me that I didn't know before? Do I actually need a Darwinian approach to figure that one out? It's like, this is not earth-shattering at all. This is in fact quite trivial. And at the same time, you're missing a lot. because if you simply reduce all of British literature or world literature to those three things, you're right in a sense, because yeah, they are about those, but you're not telling me anything new or interesting. It would be like somebody who says, look, I have an evolutionary psychological interpretation of why people go to restaurants. And that interpretation is because we have a fundamental instinct, biological instinct for hunger and thirst. And I would look at you and say, you got to be kidding, because it certainly is the case that when I eat because I'm hungry and then I drink because I'm thirsty. There's no question about it. That is not a big insight into human nature, right? But you're not going to be able to explain the variety of gourmet restaurants that you find in any major city in the world on the basis of that observation. Gourmet restaurants, gourmet cuisines, and going out as a social ritual and all that sort of stuff has a lot to do with social interactions, with human psychology, all sorts of stuff, not just with the fact that people are hungry. If you're hungry, you can just stay home and eat. That's not, why would you go to a restaurant? And why would you experiment with bizarre cuisines that feature dishes that you may not like, for instance, and that may cost you a lot of money? It's got nothing to do with just being hungry and thirsty. Yes, of course you go to dinner because you're hungry. But that fact in and of itself, which is a biological fact, no question about it, it's only a tiny portion of the general explanation of why people go to restaurants and enjoy gourmet cuisines. You have to take into account cultural evolution. If you don't figure out cultural evolution into the equation, then you're really oversimplifying and not understanding what is going on. And funny thing is, this has been known for literally 24 centuries. This criticism that I just leveled to evolutionary psychology, which is that it's kind of oversimplified and missing the point. It's been around for a long time. There is a Platonic dialogue, the Phaedo, which is about the last day of Socrates' life. Right. So it's set in the prison where he's awaiting his execution by drinking the hemlock, and he's having a conversation with some friends of his about all sorts of things, including the nature of the soul and whether there is an afterlife and the nature of virtue, all sorts of that sort of stuff. And at some point, Socrates says, when I was young, I was interested in what we today call science. And I was a student of Parmenides, who was one of the early philosophers who was interested in the nature of the world. And then Socrates says, the problem with Parmenides' approach is that he would tell you, if you were to ask him, why is Socrates sitting there in this particular moment in the cell, he would start talking about Socrates' bones and muscles and the fact that, in his physiology and all that sort of stuff, which is all true. It's certainly, it is his bones and muscles and physiology that allow him to sit down, let's say, in a particular place. But Socrates says it would be entirely missing the point. The reason I'm here is because the Athenians condemned him to death. That is the reason. In other words, it's a sociological reason. It's a psychological reason. It's nothing to do with bones and muscles. Yes, the bones and muscles are there for sure, but they are not the proper level of explanation. And this is one thing that I think evolutionary psychologists are really missing the boat on. In science, or in general, actually, in human understanding, you always have multiple levels of explanation, okay? And you need to figure out which levels of explanation of a particular phenomenon are more informative, right? So right now, for instance, if somebody were to ask me, what am I doing? I could talk to that person and explain things about the electrons that are passing between our two devices, because I'm talking to a computer, and I can do a quantum mechanical level description of what I'm doing now. And that would be missing the point, because the proper explanation is, hey, somebody a month ago asked me if I wanted to be interviewed and talk about science and pseudoscience. And because of my interests in the subject matter, I said, yes. The electrons have nothing to do with it. Electrons makes this possible, sure. So if you ask me, how is it possible that you can talk to somebody on the other side of the world? Well, that's got to do with electrons for sure. That's got to do with physics. But if the question is, why are you talking to that person, then electrons in physics have absolutely nothing to say about this. It's all about human psychology and sociology and so on, and cultural evolution and so on and so forth. And that, I think, is the problem with evolutionary psychology. It's focused on one level of explanation of biological behavior, of human behavior. And that level of explanation is certainly relevant. I mean, it's not like, we do have genes, and our genes do shape to some extent our behaviors, but it's definitely not the most fundamental, most informative of the levels of explanation. And that, I think, is the fundamental problem with evolutionary psychology. It tends to put the attention where it is actually less interesting or less informative.
Do you think that evolutionary psychology is perhaps, not simply, a descriptive claim as its proponents claim to be? Because if you read the most popular evolutionary psychologists, at least their popularizers, because it has had the privilege of having great popularizers, Steven Pinker, Robert Wright. If you read their works, there is, they're clearly not simply making a descriptive argument. With Robert Wright, it's very obvious. I know that you have had conversations with him. I'll be talking with him sometime soon. But in his book, The Moral Animal, he makes it very obvious that his claims are not just descriptive, that, oh, you should perform in a certain manner, dress in a certain manner, you shouldn't wear skimpy clothes if you want long-term relationships and things like that. Those are not science, and those are not descriptive claims. Those are prescriptive claims, and
Right.
same is made by Thornhill and Palmer.
Correct.
So it's not.
That's right.
It seems to me like even in David Buss, even in his work, you find the thread that they're not simply making descriptive claims; they're making prescriptive claims. And so, do you think that perhaps they're motivated, at least partly, by their ideological moral beliefs rather than simply by a desire to do disinterested science?
Yes, that's right. I think that's exactly right. And it's interesting that some of these people actually admit that they're not doing just descriptive work, that they're doing prescriptive work. Some of them don't admit it. They just say, no, this is just science. I'm not doing, like, for instance, Jonathan Haidt, who is a social psychologist who has done research on the psychological foundations of moral beliefs. He claims repeatedly in his writings that he's not doing anything prescriptive, but in fact he is. If you read, not even that much between the lines, that's exactly what he's doing. He's crossing that line between description and prescription, which means that he's not doing science anymore. He's doing ethics. And ethics is a branch of philosophy. Now, I do agree that my position tends to be that ethics has to be informed by facts, by science. If I want to make a good decision about what to do or not to do, that decision really should be informed by the best facts available. In other words, it should be informed by science. But one thing is to be informed by science. Another thing is to reduce it to a scientific question, right? Science is just not in the business of providing moral advice. It's just not what it is designed for. And therefore, if you use it that way, it is misuse. In the case specifically of evolutionary psychology, the danger is high because a large number of papers and books in evolutionary psychology clearly describe a set of human behaviors that fits pretty well with racist and misogynist ideas, right? Now, you could argue, look, if the facts are those, you don't get upset. It's just like it is what it is. Well, first of all, it's not clear that the facts are those. A lot of empirical evidence, as I said, it's very difficult to come by actually in evolutionary psychology. So it's not really clear that these people are right. But even if they were right on the facts, that's where you really need to draw a distinction between the facts and the ethical implications, right? So you need to be particularly careful and say, look, this is not an excuse for to behave as a racist or a misogynist. Unfortunately, a lot of well-known evolutionary psychologists have a bad track record in that area. You probably know that one of them, the founder of the field, actually, E.O. Wilson, just died a few weeks ago, and there is already a controversy about his certain attitudes that he had, certain positions that he took that are of at least aiding racists, right?
So his correspondence with Rustin.
Right, that's right. So now Wilson, he's very famous for having founding the entire field of sociobiology, which later became evolutionary psychology. And he's always said in his writings, like, no, I don't think that this research should be used to support racist ideas. But then it turns out that people are now digging into the archives, the Wilson archives, which are available at their deposit at the National Library in Washington, D.C. And so people are started reading the correspondence that he had with other colleagues. And it turns out that there are several cases of direct correspondence between Wilson and well-known racists in the United States. And in one case, he tried to help one of these people to actually survive a challenge to the tenure. This guy was a university professor, and the university wanted basically to fire him because of his racist views, and Wilson helped him. Now, that doesn't look good. If you're already criticized because you're doing research that could be interpreted as supporting racist or misogynist ideas, and then it turns out you actually were a racist or a misogynist, that's not good. That doesn't help your case at all. And so now, in general, again, I don't think that we should just eliminate the entire, dismiss the entire field of evolutionary psychology because there is a bunch of racists that take advantage of that sort of approach. That's just not fair. It's not the fault of the research itself. But it certainly means that we should take with a large grain of salt anything that comes out of evolutionary psychology, because it does have that kind of direct implications for so important social issues. It's not research into the structure of galaxies. It's hard to imagine how doing research into the structure of galaxies could be racist or misogynist. But if you're doing research on human behavior, yeah, it's very easy to imagine how people could misconstrue the results of your research. And that means that you have a responsibility to be particularly extra careful about what you do and what you say.
All right, so I know we're running out of time, so I'll have one last question. I wanted to talk about Stoicism and extended evolutionary synthesis. We'll do that sometime again. So, this is related to the last question, what you talked about, the role of public intellectuals, because the trend is that the most popular public intellectuals that we have right now are basically either anti-science or conspiracy theorists or anti-vaxxers, and they're getting millions of views. So in an age where the popular, public intellectuals are supposed to be seen as experts and guiders, in that age, we have people like Greg Weinstein, Jordan Peterson, who are propagating explicitly anti-scientific or pseudoscientific Jungian psychoanalytic ideas or anti-vax ideas. So how do you see the future of public intellectuals, and who would you describe as the ideal public intellectuals? What are the characteristics of that?
Oh, that's a really interesting question. I see the immediate future of public intellectualism as pretty bleak, precisely for the reasons that you're talking about. That there's a good number of intellectuals, good writers, Corey Robin, for instance, who is actually a colleague here at the City University of New York, and he's interested in politics and social science. He writes beautiful and very well researched and very accessible essays and books, but his audience is a fraction of Joe Rogan or Jordan Peterson. So, and there are many others. So, yeah, there is a problem here. There is an issue, and honestly, I don't know how we're going to solve it. I don't know whether and if it's going to improve. I hope it's going to get better in the future. But right now, we are in dire straits. The public intellectualism is it's not in good shape. In terms of who I would sort of bring up as role models, I don't think there is anybody who's ideal. I mean, everybody has flaws and everybody has limitations. But certainly I can tell you that my own reference points are people like Carl Sagan, Stephen Jay Gould, of course, both of them deceased now. Among the living one, Noam Chomsky, although he's getting pretty old at this point. I already mentioned Corey Robin, for instance. So there are a number. I think Sean Carroll is a good example, even though I think he's going a little bit on the fringe when he talks about the multiverse version of quantum mechanics. But he's a very thoughtful writer. He's a very smart person who knows a lot about stuff. And then the other problem, I think, is that when we talk about public intellectuals, we have to remember that there's no such thing as a sort of an all-purpose public intellectual, right? I mean, so Stephen Gould, for instance, was good because he was writing specifically for the public about biology, which was his field. Carl Sagan was writing about astronomy, which was his field. Sean Carroll writes about physics. You can't have the problem with the Jordan Peterson and the Joe Rogan and all that sort of stuff is they seem to be all purpose. They talk about anything as if they actually knew what they were talking about. And nobody knows everything, or nobody is an expert level on everything. And so that is one of the problems about modern public intellectualism. That is, we need to go back to a model where we need to listen to people that know what they're talking about. That doesn't mean that you completely blindly trust anybody. There are things that Sagan and Gould wrote that I disagree with, but that's part of the point, that you get into an argument, into a constructive conversation with these people. But if you're talking about somebody who is a factotum, who does everything, in the end, it does nothing. And unfortunately, these are the people that have, as you pointed out, the millions of followers on social media. I have no idea how we're going to solve this problem. My only consolation comes actually from a metaphor that was used by Carl Sagan. One of his best books, arguably, is The Demon Hunted World. And the subtitle of that book is Science as a Candle in the Dark. And I like this notion. I would actually enlarge it. I would expand that notion, not just science, but reason as a candle in the dark. And I think of it this way, that my goal, my purpose, and the goal and purpose of a lot of my colleagues is to keep that candle from being snuffed. That's good enough. If we can now then expand it and make it 2 candles or 3 candles, that's even better. But I don't expect anytime soon the whole world to be illuminated by reason. It's just not going to happen. A cursory understanding of science will show you that periods in which human reason peeks through and really shine are very few and far in between. But at least if we all try to do our best to keep that candle lit, then we're doing something useful for both the current generation and future generations.
Well, that's an excellent point to end on. My ideal public intellectual would also be, those people you cited, including Sam Carroll. He has excellent conversation across the sort of humanities as well as sciences in his podcast, Detailed One. So there's that. He's not dismissive. There's also Professor Dennett, who kind of combines humanities as well as social sciences. Though I don't always agree, but he's been an influencer. to me and to many others. So there's that. Professor Pigliochi, it was an honor to talk with you. Thank you very much. And did you enjoy the conversation?
Thank you very much. It was a pleasure.
Thank you.
All right. So let me